Welcome to CLRL Pods, mega hints to help solve the Phoenix puzzle. The Phoenix is a mythical bird that dies in flames and is reborn from the ashes. This puzzle involves a fictional computer disk that was written 3 times and erased twice. We are asked to recover the current and each one of its past written words. First, it will take a little simple math. Then, once you understand what to do, it will take some moving around a bunch of digits to decode the messages, but no additional math. I'll give you some tips to do it faster in Excel, but you can do it with just paper and pencil. Information is stored in our fictional computer using the binary ASCII system. The binary system has only 2 possible states, 0 and 1. In our case, 0 is defined as 1 volt plus or minus 0.3 volts, and 1 is defined as 5 volts plus or minus 0.3 volts. In other words, any voltage between 0.7 and 1.3 is considered to have a value of 0, and any voltage between 4.7 and 5.3 is considered a value of 1. In the ASCII system, each letter or number is stored in locations or bits that forms a byte. Therefore, each byte has 8 bits, and each bit has a voltage that can be low, around 1 volt, or high, around 5 volts, representing respectively a 0 or a 1 value. For instance, number 5 in ASCII code is 00110101, and their voltages would be originally 1155, 1515 volts respectively. You may find useful to think in terms of 2 groups of 4 bits for each byte. These are called nibbles. Let's now see what happens when our fictional computer erases its memory. The puzzle states that it removes 95% of its value, leaving only 5% left. So a memory bit with a 0 value has 1 volt before erasure, are 1 times 0.05 or 0.05 volts after the first erasure. And a memory bit with a 1 value has 5 volts before erasure and 5 times 0.05 or 0.25 volts after the first erasure. After the first erasure, the memory is written again with 1 and 5 volts for zeros and 1. So the bit that had a 0 before goes from 0.05 to 1.05 if a 0 is written, and from 0.05 to 5.05 if a 1 is written. And the bit that had a 1 before goes from 0.25 to 1.25 if a 0 is written, and from 0.25 to 5.25 if a 1 is written. So a value of 1.05 means that the first writing was a 0 and the second writing was a 0 too. The value of 5.05 means that the first writing was a 0 and the second writing was a 1. Do you get the idea? The final value tells you the history of what was written before. There was then a second erasing and a third writing. Do the calculation again, and you will end up with 8 different values, each representing the previous zeros or ones combinations. For instance, we determined that the bit with a value of 1.25 volts at the second erasure had a 1 and a 0 written in the previous 2 writings. If you erase it, you will now have 1.25 times 0.05 or 0.06 volts. Write then with a 1 and it will have a value of 5.06 volts. Therefore, a value of 5.06 means a 1, a 0, and a 1 history. To solve the puzzle, take the given values and determine the 3 previous states for each one. Then Google binary ASCII and find the binary ASCII values for the whole alphabet and numbers. If you want to use Excel, you can select and copy the values from the puzzle page, paste it in a notepad, and then save it as a text file. Go to Excel, Data, Import External Data, Import Data, follow the defaults, and the data from the puzzle page will be in your Excel worksheet. Select it and copy it twice so as to have 3 sets of the same data. Then select the first group and use Edit Replace to replace each voltage with a 0 and 1 corresponding to the first writing. You'll end up with all the voltage values replaced with zeros and ones. You then read them horizontally using the ASCII code to get the first letter of the hidden message. Repeat the process using the values for the second writing on the second group of voltages pasted on Excel, and again with the third group. You'll find the 3 writings hidden in the fictional hard disk. Good luck and happy geocaching!